In this video, we're going to look at how to solve an exponential equation by utilizing factoring. But before we do this problem here, just want to review the typical procedure for solving an exponential equation. So let's suppose we have 7 to the x is equal to 5. If we have just one exponential, which is the case here, we'll isolate it. In this case, it's already isolated. So if this is written 7 to the x minus 5 equals 0, we write it this way. And then we simply take the log of both sides. It could be any base. Normally you're going to deal with base 10. Or in this case, I'm using natural log to base e. So I take the natural log of both sides. I get this right here. And then there's a property of log that allows me to take this exponent here as a coefficient, so I can rewrite the natural log of 7 to the x as x times the natural log of 7, and that's equal to natural log of 5. And then of course I want to solve for x, so I divide both sides by ln of 7. So I get x is equal to natural log of 5 divided by the natural log of 7. Use your calculator, and to 3 places that comes out to 0.827. If you have a more complicated exponential, you could still solve it. In some cases you can use graphing. Here, for example, I can rewrite as 7 to the x minus 5 is equal to 0. And I've done some videos like this before. This is in your, say, f of x. This is your f of x. And I could graph it. So on a calculator, you just enter the 7 to the x minus 5. Already entered it here. 7 to the x minus 5. And I simply graph this, and where this graph crosses the x-axis, those of course turn out to be the zeros of the function, which of course in this case would be the solution. So if I decide to graph it, okay, I can graph it look something like this, and right there where it crosses the x-axis, that's the x-intercept. The x value is also the 0 of the function, or in this case, turns out to be the solution. So what we do is we go to second, calculate here, and we do the number 2, which is 0. Hit 2, and then it wants a left bound, so I put this to the left. Hit enter. Now it wants a right bound. You just go up the curve here a little bit till you get past the point of intersection. Hit enter again. Now it wants you to guess. You can ignore that and just hit enter. And it tells you that x is equal to 0.827. Round it out to 3 places. Y equals 0. So that's guaranteeing that this is a 0, or in this case, it's a solution. So we got 0.827. Which is the same thing we got here. Okay, so those are some ways to solve an exponential. Now if you look at this one here, we have e to the 2x plus e to the x is equal to 6. So we have different exponents here. The base is the same, but we can't isolate one of these. So what we can do here, write this as e to the 2x plus e to the x, and then add minus 6 to both sides to make one side 0 here. Now we could solve this equation here by simply taking this right here and entering it into the calculator and graphing it. And again, where it crosses the x-axis, that's going to be the solution to this. But I want to demonstrate another procedure here. And just look at this as, you can see that this is, let me write it up here. I can write this as e to the x squared. It's a power to a power. We multiply the exponent, so this is the same thing as this. Plus e to the x minus 6 is equal to 0. Now you could use a u substitution if you wanted to here and say, well, this is just let u equal to e to the x, then do this. And this is just u squared then, plus u minus 6 equals 0. So it's a quadratic in u. Okay. And then you could solve for u, replace the u by e to the x, and get your equations. But don't think I had to do that. I could just go ahead and just factor this the way it is. And say, this is going to factor into e to the x plus 3 and e to the x minus 2. Equals 0. Okay. So we have the product of two factors equal to 0. The only way that can happen is if one of the factors is 0, or if both factors are 0. So simply set each factor equal to 0 and solve. Okay, so let's just say e to the x then. Setting this e to the x plus 3 equal to 0, and adding negative 3 to both sides, I get e to the x is equal to negative 3. And then taking the second factor, setting it equal to 0, I would just add 2 to both sides. This would give me e to the x equal to 2. Now the exponential e is approximately 2.718 to 3 places. 2.718. And it's positive. So you take that, any positive base to any exponent, it's always going to be a positive number. It's never going to be negative. So this one right here has no solution. It's an empty set. Now this one over here, e to the x is equal to 2. That one I can do is just like the first one I did here. I take the log of both sides. It could be log to base 10, or it could be the natural log base e. And in this case, even though both will work, because this is e, it's a lot easier if you take the log of both sides to base e. So we got natural log of e to the x, and taking the natural log of the other side. Now keep in mind that ln has a base v. So remember that when you have natural log, that's the same thing as you get log with no base. This is understood to be base 10. Okay, this one with no base is understood to be base e. It's just understood, we don't write it in. Okay, so here we're saying the natural log of e to the x. Because it's e here and e here, that means that the left side is just x. So that gives me x, and it's equal to ln of 2. Now, if they want an exact answer, you just give natural log of 2. If they want an approximation, then you could use your calculator and compute this out, say to 0.693. The exact answer is natural log of 2, or approximate 2 places, 0.693. Thanks for watching. We'll see you next time.